Somewhere in your city right now, a tree is growing that could replace your fuel bill, end your vitamin deficiencies, and purify dirty water in 30 minutes using nothing but its seeds. Not a lab, not a pharmaceutical plant. A tree. One tree. And the reason you have never been told its name is not an accident. It is a decision made over a century ago by men who understood one thing very clearly. You cannot build an empire on something that grows for free. If this is your first time here, click on the subscribe button now. Every week, we dig into the knowledge that was buried so that dependency could be sold back to you. Subscribe now and hit the bell so you do not miss what is coming next in this archive. This is the story of Moringa, the tree that solved 3 global crises before a handful of oil and chemical industrialists decided that solving problems was less profitable than selling the problem. The archive opens in northern India, 2000 BCE. A tree grows in dry, cracked soil where crops fail and rivers dry up. The people call it Shigru, the miracle tree. They eat every part. Leaves like spinach, pods like beans. They press seeds into lamp oil. But here is the detail that kept entire civilizations alive during drought seasons. When the wells run dry and the water turns brown, they crush the seeds into powder and drop them into clay pots of murky water. 30 minutes later, the water is clear. The sediment has sunk. The bacteria are dead. They do not have the science to explain why. They just know it works. And that knowledge will quietly save millions of lives across 4 millennia before it is deliberately buried. By 600 BCE, Ayurvedic physicians are documenting Moringa as a treatment for over 300 conditions. The Romans import it from Egypt and India at premium prices, specifically for an oil that never spoils and never freezes. Arab traders carry it across the Silk Road. In Africa, it spreads through the Sahel, the strip of land where nothing else survives a drought, because Moringa does not need rain to thrive. It needs almost nothing, and it gives back almost everything. 2 discoveries in the 1800s begin to reveal how extraordinary this tree actually is. British colonial botanists catalog every edible part. Roots that taste like horseradish. Flowers that go raw into salads. Young pods that cook into curries. Mature seeds that yield clean oil. Even the leftover seed cake that remains after pressing feeds livestock. In 1892, chemists begin measuring the leaves with precision. 7 times the vitamin C of oranges. 4 times the calcium of milk. 4 times the vitamin A of carrots. 3 times the potassium of bananas. 2 times the protein of yogurt. This is not a vegetable. This is a complete nutritional system growing on a single tree. The second discovery is the oil. Moringa seeds contain between 38 and 40% oil by weight. That oil is 70% oleic acid, chemically identical to olive oil. Cold-pressed with no refining needed. It burns clean. It does not smoke. It does not freeze. And here is the detail that would quietly ignite a conflict spanning the next century. It runs diesel engines. 1900, Paris World Exhibition. Rudolf Diesel demonstrates his new internal combustion engine to an audience of engineers and investors. He does not use petroleum. He uses peanut oil. He writes in his journal afterward that the use of vegetable oils for engine fuels may seem insignificant today, but such oils may in the course of time become as important as petroleum. Researchers begin testing alternatives. Moringa oil works. Cottonseed oil works. Sunflower oil works. The engine was never designed to require petroleum. It was designed to run on plants. What happens next erases that reality for 100 years. 1908, Henry Ford launches the Model T. It is built as a flex-fuel vehicle. It runs on gasoline or ethanol derived from corn, hemp, or any fermentable plant material. Ford tells reporters plainly that there is fuel in every bit of vegetable matter that can be fermented. His vision is one where every farmer grows their own energy. 2 futures are taking shape: petroleum or plants, centralized extraction or distributed abundance. One industry moves quickly to decide for everyone. By 1870, one industrialist had already built an oil refining operation in Cleveland, Ohio. By 1880, his trust controlled 90% of oil refining in the United States. But his operation did not just sell oil. It built a system designed to make oil the only available option. Pipelines across Pennsylvania, refineries in New Jersey, distribution networks spanning 30 states. Kerosene sold below cost to bankrupt every competitor. Then prices raised once the competition collapsed. By 1900, his company was the largest corporation in the world, and he had become the first billionaire in American history. But electric light was replacing kerosene lamps, and his empire needed a new product. Gasoline, the waste byproduct left over from kerosene refining, became that product. The automobile did not just change transportation. It saved the oil industry. And what followed was not simply commerce. It was architecture, the deliberate construction of a world where no alternative could survive. In 1913, after courts broke up the oil trust into dozens of successor companies, those same interests established a private foundation with an initial endowment of $182 million, the equivalent of more than $5 billion today. The stated mission was to advance human knowledge and end hunger. The actual method was to fund universities, research institutions, and agricultural programs in ways that made farming dependent on petroleum at every stage. Between 1943 and 1963, millions were poured into agricultural research. Every major project carried the same logic. Replace what is natural and free with what must be purchased. Horses replaced by tractors. Animal manure replaced by synthetic nitrogen fertilizers made from natural gas. Traditional pest management replaced by pesticides derived from petroleum byproducts. Diesel pumps replacing hand irrigation. If farmers needed petroleum to plant, fertilize, irrigate, and harvest, then the oil industry effectively controlled the food supply. Meanwhile, alternatives vanished. In 1920, ethanol was available at filling stations across the United States. Farmers distilled it from corn. By 1925, industry lobbying had ensured that only gasoline was sold through major distribution networks. States passed laws restricting ethanol sales. Infrastructure locked in. Every pump sold petroleum. Every engine was redesigned around it. Vegetable oil research disappeared from engineering schools. Rudolf Diesel died in 1913 under circumstances that remain disputed. He fell from a ship crossing the English Channel while traveling to a business meeting in London. His body was recovered 10 days later. The official finding was suicide. His vision of plant-powered engines died with him. By 1930, petroleum was not a choice. It was the only option that existed. But suppression requires more than eliminating alternatives. It requires replacing traditional knowledge with dependency at a global scale. In 1943, a major agricultural initiative launched in Mexico, funded by oil-aligned foundation money with an initial investment of $800,000. The stated goal was to increase wheat yields. The method was to breed high-yield seed varieties. But those seeds required something that older varieties did not: synthetic fertilizers, petroleum-based pesticides, and diesel-powered irrigation. This became the template for what would later be called the Green Revolution, exported through the 1960s, 70s, and 80s to India, Pakistan, the Philippines, and across sub-Saharan Africa. Governments were pressured to adopt industrial farming. Traditional agriculture, which had relied for centuries on trees like moringa for nitrogen fixation, nutrition, and drought resilience, was labeled primitive. Millions of acres of food forests were cleared for monoculture wheat and rice, all requiring constant petroleum inputs. International aid and lending was tied to the purchase of tractors, fertilizers, and pesticides. Countries that had fed themselves for thousands of years began importing both food and fuel. This was not failure. This was the intended outcome. And while it was happening, researchers kept studying moringa. In 1992, a published study demonstrated that moringa seeds purify water contaminated with bacteria. The proteins in the seeds bind to E. coli, salmonella, and cholera, causing them to clump and fall out of suspension. Bacterial reduction ranged from 90 to 99%. In 2007, the World Health Organization documented moringa use for water purification in rural communities across 14 countries, noting that a single tree produces enough seeds to purify water for a family for an entire year. In 2011, a comprehensive review published in Phytotherapy Research examined nutritional data across 17 independent studies. The data was consistent. Per gram, moringa leaves contain more iron than beef, more calcium than milk, more vitamin A than carrots. To be precise, 100 grams of dried moringa leaves contain 25 grams of protein, 2,300 milligrams of calcium, 28 milligrams of iron, 19 grams of fiber, and 16.3 milligrams of vitamin C. The USDA published this data. Universities studied it. The science was documented and available. International development agencies continued to ignore it because Morina offers something those agencies are not designed to deliver: solutions that cannot be monetized. Here is what one mature Morina tree actually produces: between 400 and 600 seed pods per year, each containing 15 to 20 seeds, each seed holding 40% oil by weight. One tree yields 3 to 5 liters of oil annually, enough to run a small diesel generator, enough to power a home. Plant 100 trees across a village, and you have energy independence. No drilling, no refineries, no price shocks tied to geopolitics. Trees growing on land unsuitable for industrial crops. The leaves are harvested fresh year-round in tropical climates without killing the plant. Enough to provide complete nutrition for multiple families. Vitamin A to prevent blindness. Iron to prevent anemia. Calcium to build bones. Protein to sustain growth. Food security that costs nothing after the first planting. Water purification requires no equipment. Crush the seeds into powder. One seed treats 1 liter of contaminated water. Stir, wait 30 minutes, and the bacteria and sediments sink. Research from the University of Leicester in 2005 confirmed its effectiveness against E. coli, Bacillus subtilis, and Staphylococcus aureus. One tree produces thousands of seeds annually, enough to purify water for dozens of families. No filtration systems, no chemical treatment, no infrastructure budget, just seeds. So here is the question this history forces. Why do 3 billion people still lack reliable access to clean water? Why do 800 million face chronic malnutrition? Why does the global South continue importing diesel at prices that collapse local economies? Because the institutions designed to solve those problems were built on logic that requires dependency. Institutions shaped by the same financial interests that buried plant-based fuel, dismantled traditional agriculture, and replaced distributed abundance with centralized extraction. But Morina never disappeared. It still grows wild across India, the Philippines, Kenya, Tanzania, Senegal, Haiti, Nicaragua, and more than 40 other countries. In the places where you cannot suppress a tree that refuses to die in drought. You cannot erase knowledge that lives inside seeds. An empire can control oil for a century. It can reshape food systems across continents. It can fund the institutions that define what counts as development. But it cannot kill Morina. It grows in the margins, along roadsides, in forgotten corners where the pipelines never reached. It has been waiting, as it always has, for a world willing to remember that solutions existed long before problems became profitable. If this opens something for you, subscribe and hit the bell icon so you never miss the next video. Every like, every share, and every comment keeps this knowledge alive.